Today we're going to look at measuring segments. There's a whole lot of definitions of postulates that you need to learn in this unit. And there's some geometric nuances. Like I've told you, there is a special language to geometry and you need to study it. So the ruler postulate basically says that the posts on the line can be matched 1-to-1 with real numbers. So it's basically just defining a number line. We're saying that for A, there's a point. So every point has a number. This point has the number 2, this point has the number 3, this point may be 5.5, but every point on a number line can be associated with a real number. The other part of the ruler postulate says that the distance between 2 points, A and B, written as this, and this is very important, this means distance, is the absolute value of the difference of the coordinates A and B. Okay, so what does that mean? It means that the distance AB is equal to the absolute value of A minus B. So if you were finding BD, B is -4, so it's the absolute value of -4 minus 7. Which would be the absolute value of -13, which is 13. If you were finding that distance between A and C, it's going to be the absolute value of -8 minus 2, or the absolute value of -10, and that's 10. And lastly, for C and D, it would be 2 minus 7, the absolute value of that, which is the absolute value of -5 or 5. Okay, so whenever you see this on a worksheet, test, or quiz, 2 letters next to each other like this, you should know that it's the distance between those points. Okay, we also have this thing called the segment addition postulate. And it says that if B is between A and C, then the distance between A and B plus the distance between B and C is equal to the distance between A and C. And then if A and B plus B and C is AC, then B is between A and C. So that's the converse of that. And that's also true. So you could write a biconditional for that. So basically, it's just saying that we've got B between these, okay, and this plus this equals the whole thing. So we want to find CD. So remember, we're going to find the distance between C and D. As an example, we know that CE, distance between it, is 42. And we know the distance between D and E is 17. So by the segment addition postulate, we know that CD plus the distance between DE is 42. And we know that DE is 17. So if we subtract 17, we know the distance between C and D is 25. Okay, so that reads the distance between C and D is 25. Here's another example using the segment addition postulate. We know that NP plus PQ equals NQ. And by our diagram, we're given that NP is 2x, PQ is 3x plus 5, and NQ is 41. So we get 5x plus 5, when we combine like terms, is 41. If we subtract 5 from both sides, we get 5x equals 36. And then if we divide by 5, x is 36 fifths. Okay. Now you're not done, and this is one of the key things in geometry too, is make sure you read the problem. Here's x. In algebra, we usually stopped at x. With geometry, we're asked to find PQ. So we're just going to substitute in 36 fifths. So PQ, that distance, is 3 times 36 fifths plus 5. So if I multiply that out, I'm going to get 108 fifths, and then this is 25 fifths. So that is equal to 133 fifths. So PQ is equal to 133 fifths. Okay. Congruent segments. Congruent segments, this is just saying that two segments have an equal measurement. Okay. These little tick marks mean that they're congruent. So in this diagram, so those tick marks there, we say that AB, and it's the segment, is congruent to segment BC. Okay. Over here, if I have different ABs or different segments, I can use 2 tick marks, I can use 3 tick marks, it doesn't matter. But again, AB is congruent to CD. Okay. So this is what I call a little geometric nuance, and it's important that you understand this. Segment measures are equal, and segments are congruent. So if I have PS U W, and I know that this is 5 centimeters and this is 5 centimeters, okay, we can say that the measures are equal, so the distance between PS is equal to UW, okay, because they are 5 centimeters long, and because their measures are equal, they're congruent. So we're going to be proving things congruent, okay, and you have to go through these steps, okay. And we're gonna do this later in that unit, but before you can say something's congruent, unless it's given to you congruent, you have to state that their measures are equal. I know it seems obvious, but there's just little classic rules to geometry. Okay, so remember, this means equal, they're equal measures. This means congruent. They are not the same thing. Okay. A midpoint is a point that divides a segment into 2 congruent segments. Okay, so in this case, B is the midpoint of AC, and it's that midpoint because we're given by this diagram that AB is congruent to BC. Now in this case, we're actually given that those are congruent. Okay. Now a segment bisector can be a point, a line, a ray, or a segment that intersects a segment at its bisector. So in this case, ray BD, okay, is a segment bisector. Because B is the midpoint. Okay. So if I know that A is the midpoint of XY, you want to find the distance between XA and XY. So if it's the midpoint, we know that these are congruent, or their measures are equal. So 3x equals 5x minus 6 If I subtract 5x from both sides, negative 2x will be negative 6. And if I divide by negative 2, x equals 3. And again, we're not done. We want to find xa. So xa is 3x, or 9. And ay is 5x minus 6, or 15 minus 6, which is 9. But we actually probably didn't need to go through this because we knew this was a midpoint, so their measures were equal. But that's just a way to double check your arithmetic and your math. Okay, so today you learned about the ruler postulate, the segmented distance postulate, midpoints, bisectors, and you have to know the difference between measurements and congruence. I will be marking things wrong on your quiz if you don't use them correctly. Have a mathtastic day.